Welcome once again to this physics series of questions, and under this aspect we are going to consider speed, velocity and acceleration. And the basic thing is for us to understand how to solve the question on speed, velocity and acceleration. Now let's consider what this question describes and let's see how we can solve it step by step in a simpler way. Now the question is, a car at a constant speed of 15 meters per second for 30 seconds and then accelerates uniformly to a speed of 25 meters per second over a period of 20 seconds. The speed is maintained for 300 seconds before the car is brought to rest with uniform deceleration in 30 seconds. Draw a velocity time graph to represent the journey described above. From the graph, then you are asked to calculate the acceleration while the velocity changes from 15 meters per second to 25 meters per second. Now, total distance traveled in the time described and the average speed over the time described. Now, the basic thing is that we want to draw the velocity time graph of this question. Now, how will you draw the velocity time graph in this case? Now, we are given that a car runs at a constant speed of 15 meters per second for 300 seconds. Now, we are not told that the car starts from rest, and this is your velocity. This is velocity in meters per second, and this is your time in seconds. Now, it runs at this speed of 15 meters per second for 300 seconds. That means at 15 meters per second, this is 15 meters per second, it runs for 300 seconds. That is 300 seconds. Now, and then accelerates uniformly to a speed of 25 meters per second. And then accelerates from this point, it now accelerates uniformly to a speed of 25 meters per second over a period of 20 seconds. Over a period of 20 seconds. So 20 plus 300, that gives us 320 over a period of 20 seconds. Now the question now go further and say that this speed is maintained for 300 seconds. Now this speed at 25 meters per second is maintained for 300 seconds. Maintained for 300 seconds. And that is 300 plus 320, that's 620 seconds. Now, before the car is brought to rest with uniform deceleration in 30 seconds, the car is now brought to rest with uniform deceleration in 30 seconds. 30 plus 620, that gives us 650 seconds. Now, the question is now that the first thing, draw a velocity time graph to represent the journey described above. So this is how you have the velocity time graph to represent this whole motion of how the car moves from where we start to observe it to when it comes to rest. Now, from this question, we are now asked, now from the graph, find the acceleration while the velocity changes from 15 meters per second to 25 meters per second. Now, we want to calculate the acceleration. This is the acceleration. This is where you have the acceleration, and this is where you have the deceleration. Deceleration. And this is where you have your constant speed. Now, we have explained velocity time graph, and under that, all this has been explained. If you are new to this channel, ensure you subscribe to this channel and check the link below this video to see what we have explained under the velocity time graph and how it is. So this is how you represent the motion that you are given in this question. Now, we want to calculate the acceleration between 50 meters per second to 25 meters per second. We know that acceleration is equal to change in velocity over change in time. And when you talk about that change in velocity, that means acceleration is equal to v T2 minus V1 over T2 minus T1. Now from here, what's our V2? That's the final velocity that we have here. And that is 25 minus V1, that's 15. Then the time frame at which it changes, 300 to 320. So our T2 is equals to 320 minus 300. So when you work that out, you are going to get 25 minus 15, that is 10, divided by 320 minus 300, and that is 20. So this cancel this. So the answer is 0.5 meter per second square. That is the acceleration, and that is the first thing we are asked to calculate. Now, the second question says that total distance traveled in the time described. Now, this is A. Now, for B, which is total distance traveled. Total distance traveled. Total distance traveled is equals to area under the graph. Area under the graph. Area under the graph. Now, this is the area of the O shape that we have in there. You can see that we can divide this shape into 3 equal parts. Now, the first one is this, A. That's area of this rectangle. And this shape that we have here. Now, let's quickly label this. Let's say you're having A, B, C, D, E, F, G, H. Then this is, let's say, O. Now, total distance traveled is equals to total area, and that gives us area OA, BH. OABH plus, now this is a trapezium, and that is BC, GH. Then this is another trapezium, and that is plus CD, G, and that is it. C, D, E, and G. So how will you calculate the first area? Area of this rectangle is equals to length times breadth. Now the length here is 300 and the breadth is 15. So this is equals to 300 times 15 plus, now the area of this trapezium is half into bracket A. Now our A is going to be BH here, and BH here is 15. Half into bracket 15 plus the other B is going to be the height here, and that is 25. 25, then multiply by the height. The height is the difference between these values. That's 320 minus 300, and that gives us 20. Then plus the other, this is CD, is the other A, and the difference between that is 620 minus 320, and that gives us 300, and that is another trapezium. So it's going to be half into bracket 300 plus the total length from here. That means 650 minus 320. This is our other B for this trapezium. So I'm having this one A, this is B, and this is C. Now for C, now that's what we are looking at. 650 minus 320, that is 330. Then multiply by the height. The height is now 25. So we can now calculate this out to get the value of our total distance. So in that case, you can see 300 multiplied by 15. That's 4,500. This is 4,500 plus. Now when you sum up this one will give us 40. times 20 divided by 2. Now from here you are going to see now that we have calculated the first part. Now in calculating the second part of it, and that is half into bracket 15 plus 25 multiplied by 20. So this is half. 15 plus 25 is 40. 40 times 20 is 800. 800 divided by 2 will give us 400. Then plus the last one, which is the area of this third trapezium. So it's going to be half into bracket, this is our A plus B multiplied by height. So in that case, you can see half into bracket 300 plus 330, then multiply by 25 and divide by 2. So you have that 300 plus 330, that gives us 630, then multiply by 25 divided by 2. So we have it as 7,875. Now when you sum up everything now to get the total distance is equals to everything sum up plus 400 plus 4,500. So that gives us 12,775 meters. Now this is how we calculate the total distance, that is like what the question says, total distance traveled in the time described, that is 12,775 meters. Now the third question is what? Average speed over the time described. The total time described there is 650. Now this is total distance. So when you talk about average speed, we know that average speed is equal to total distance over total time. Now our total distance from here is 12,775 divided by total time. Total time is what we have here, and that is 600.